So good morning, everybody. Good morning again, and welcome after this coffee break. We are not many, but we are good, and it's a pleasure to me to host this session. My name is Paulo. I'm Paulo Ferreira. I'm coming from the University of Coimbra, and I'm also here as a member of the board of Tecnicelpa since 17 years. It is a pleasure to share this session where we gather 3 presentations on new papermaking components, namely a novel additive to replace cationic starch, a new coating with barrier properties for food packaging, and an alternative fiber furnish for tissue papers. Each presentation will last approximately 15 minutes or something between 15 and 20, so that we can have at least 5 to 10 minutes at the end for a Q&A period. The first presentation is from Christian Biermann, that holds a PhD degree on organic chemistry from the University of Munster and has worked in the paper industry since 1996, beginning his career at ASCO-Nobel. As Application Excellence Manager for Wet End Solutions at Chemira, he helps customers optimizing retention and strength applications. His field insights from customer challenges contribute to the development of new products and innovative concepts at Chemira. Please, Christian, the floor is yours.
Thank you very much. Yeah, thank you very much for this very kind introduction, and welcome everybody to my presentation on our product FENNOBOND 777E, the convenient pump and go solution for superior dry ceramics. So that's how I titled the presentation. Okay, sorry. The last presenter was a little bit smaller. And that is how I titled the presentation, and let's see if my presentation or what I present can live up to what I said. Content, the first step after the kind introduction, I can skip, so we don't need to give a few words additionally on myself. And in my presentation, I want to speak a bit about the background. So why is dry strength important, and what is the right to use dry strengths or the reason to use dry strength agents. Next is I will give an overview on common products used to generate dry strength. Then I will introduce the product FENNOBOND 777E to you. And last but not least, there will be 3 case studies on the application of this product. So dry strength. Dry strength is really key quality requirement of paper. So it describes the functionality of paper, and when, for instance, when you look on test liner, you have test liner 1, test liner 3, test liner 2, and the main difference is the strength property of the paper. Of course, runnability of the paper and converting is decided by the strength of the paper, and of course, selling price is according to the strength of the paper. But why should people use dry strength additives? Because one thing is for sure, when you start using a dry strength additive, you will add additional costs to the production of your paper. So there must be a payback for you why you are using the dry strength agent, because otherwise you just create costs. And I have 2 subpoints here. One is it's all about money. So production costs are decisive, runnability costs are decisive, raw material costs, of course, are decisive. And as we could see in the last presentation, out-of-spec production, of course, are also cost driver. And luckily, it's not only about money. So also there are new developments. People try to develop better paper, which gives them a competitive edge, which will be able to produce new innovative products, which then allows them to ask for a higher price for their products. And I want to talk a bit about a few selected key drivers. One, when we look on virgin fiber papers. Here, the price gap between long fibers and short fibers is decisive and would generate easily calculatable benefits for the paper mill. In recycled fibers, it's a little bit more complex. So, I mean, the price differences between recycled fibers, it's not that huge, but sometimes the quality is not available a paper mill needs, or there's still a cost pressure to use as cheap fibers as possible. Energy costs, especially in Germany, they are huge. So I was really surprised how much a paper mill is paying for electricity and gas running a paper machine. And it's, let's say, for a testliner machine producing 300,000 tons of paper, it was about 120 million euros in Germany to cover the energy costs. I find that a huge amount of money. So if a dry strength agent is able to provide energy savings, of course, that may be an easy to calculate value as well. Last but not least, development of new paper grades. So some mills, which are usually producing testliner, try to develop kraftliner substitute, so much higher strength paper. Lightweighting of board is around for many years, that people would like to have cardboard, which is lighter in weight, but providing the same strength. And yeah, sometimes again, out of spec production, if a mill has a certain paper grade where they are struggling with reaching the strength, in these grades, if the dry strength enables them to stably or dependably reach the strength targets, that of course will save money for them. Okay, let's start with the virgin fiber or the price gap between long and short fibers. So these are market prices, and I assume in Portugal, for instance, the eucalyptus price may be lower than this market price given here. The light blue line, which you see here, is the long fiber price. The dark blue line is the short fiber price, and the red line plots the price difference. And as you can see, there was like a peak in 2023 that came down again, but more or less since the beginning of 2024, the price gap seems to stay stable at 400 euros per ton of fibers, and the predictions are that it will stay like this. So if you can save on long fibers, you will really make a lot of money for the paper machine. Recycled fiber qualities. I started in paper chemical industry in 1996, and then it was said, the fiber quality is so poor, it's more and more difficult to reach the strength targets. When we look on the recycling rates in Europe, we can see more or less since about 2015, we are having a kind of continuous recycling rate, about 70-something%. And that is probably where we will be staying. So paper will not be more often recycled. EU target is 76% in recycling rates. Some countries nowadays are already above this target, and some countries are below this target. So I'm quite positive that we will reach this target. But bottom line is recycling of paper is not the reason why the paper quality is going down. I think bigger reason is when you look on the production. I picked the production of containerboard and the production of kraft fibers, long and short kraft fibers. Again, the light blue line is production of containerboard, the dark blue line production of kraft fibers, and the red line is kind of the percent points between these productions. I took 2013 as 100% and then plotted the change of production. And as you can see, less kraft fibers are produced, more containerboard is produced. So I think that is the main reason why the fibers are getting weaker and weaker, because less fresh fibers, less strong fresh fibers are reaching the recycling circuit. Then maybe a comment. No, I don't comment on this one. I go to the next slide because it's a little bit speculative. So the next slide here, we have an overview about common dry strength products. So in recycled fibers, if somebody wants to use a wet end dry strength agent, quite often paper mills use on-site GPAM. On-site GPAM is glycolated polyacrylamide. The conversion is done at the customer side. Drawback of this technology is that the customer has to do the conversion step at the paper mill, which requires some heavy equipment, and of course handling of the glyoxal. Strength gains are really good, so there are reasons why people are using this on-site GPAM. Then there are some ready-to-dose GPAMs available. Those are extremely easy to apply, just pump it and that's it. Disadvantage is the strength gains are not as good as with the on-site GPAM because these products are not as reactive as the on-site GPAM is. Cationic wet end starch, it's a great strength additive, it's sustainable, so it's really good. Disadvantage is due to system closures, increased conductivity in recycled fiber machines, you need to use very expensive, highly cationized starches to reach strength, and even then you may not get strength. Additionally, you are feeding additional food to the bacteria in your system, so it's not preferred. Surface starch is really, in testliner production, for instance, is really the state-of-the-art technology. High strength gains, cheap starch available, but your paper machine needs to have a size press or film press. Limitation is you can just add a certain amount of starch. If you go above this, your paper may become brittle, may break when you bend it or crease it. That is a disadvantage. So even with this highly developed technology, you may reach a point, you cannot go beyond this point anymore. And then additional strength will be required coming from the wet end. Experience is that usually the wet end strength gains are on top of the strength gains achieved by the surface treatment. Okay, those, to my understanding, are the currently used products. I didn't include enzymes because I don't know so much about enzymes, so everything I would say would just be coming from literature. Now let's look at the FENNOBOND 777E. So the properties of the product are similar to the ready-to-dose GPAM product. So it's a pump-and-go product, which means we need a pump, some dilution water, and a dosing point somewhere in the thick stock. So it is really easy. Solution is about 19% plus minus, and strength gains are in the range of on-site GPAM, so the highest possible strength technology we know. The limitation is the concentration of the solution. So if a machine produces, for instance, 60 tons per hour, if you want to dose 10 liters per ton of paper, that means you are dosing 600 liters of the product per hour to the paper machine circuit. So really big machines will struggle a little bit, or you will have to have the storage capacities. But my experience is in reality, paper machines are not always using strength additives, so it's more for certain grades, reserved for certain grades, and then even big machines may be able to handle the volumes. So that is the only disadvantage I can see. When we look at the dosage, it's similar to on-site GPAM, 1 to 3 kilograms per ton on active, and required food contact approvals exist, eco-labels exists. So, and I don't know, it's also possible to produce a biogenic product. There we use the acrylamide, the monomers for producing this product. We use actually from black liquor. So it's amazing what can be created nowadays from black liquor of a pulp production. So that's really nice. And let's say the part of my title, the convenient pump and go solution. Okay, I could show to you it is convenient to use, easy to use, but can it really give superior dry strength? That's the big question. Let's go to the case studies. The first case study is a napkin producer. He produces colored and white napkins, and they wanted to increase the amount of long fibers in their fiber mix. Due to the before mentioned reason, 400 euros price gap is money. And it's a quite modern machine, 1,500 meters per minute, 100% virgin fibers. And they also wanted to reduce the dusting in converting because that was slowing down their converting. At this machine, we started to dose 8 liters of FENNOBOND to the mixing pump, so right at the end of the thick stock. And that enabled them to increase the amount of long fibers or to decrease the amount of long fibers by 25%, which generates like 200 kilo euros per year of net savings. So net saving means after our product costs are subtracted. And when we got this result, we thought, okay, now we are in. Now they will start to use our product. But they were still a little bit reluctant. And we were a bit surprised, but when the customer started to convert the product, they saw that the cleanliness of the converting line completely changed. So on the left picture, you see the converting line after converting one reel. On the right picture, you see the converting line after reducing the long fibers, increasing the short fibers, and using the FENNOBOND 777E. So much less dust in the cabinet, and due to this, they need to clean after every 4 reels, which increased their productivity by 60%. And maybe one thing which I didn't mention so far, what we observed was, even though our product is cationic, we see a very small impact on the system's charge of the system. So zeta stays more or less stable, and colloidal load also stays stable. And as said, this paper machine produces some highly colored grades, and then they need to use a lot of fixative to avoid bleeding of the colors. And we were a little bit afraid that we get too close to the isoelectrical point. But this didn't happen. So the machine stayed anionic all the time, no runnability issues like foam or otherwise. So that's really nice, that we have no limitations, even if the machine is close to the isoelectrical point. So that was really nice. And then the next case study is again a tissue machine. And again, they wanted to replace long fibers. And actually, they wanted to decrease the energy consumption. It's again 100% virgin fibers and 1,600 meters. And this machine is really like a model case for all benefits which we consider to be possible to reach with the product. So here we dosed 12 liters per ton of FENNOBOND before refining, so at the very beginning of the thick stock. And they increased the short fibers from 50% to 75%, which I heard is still a high dosage of long fibers in Portugal. Daniel said that it's sometimes 4 or 5% of long fibers in the tissue production here, so very different maybe. But what was nice, they could decrease the refining of the long fibers as well. That of course generates a little bit of energy savings, but that's not a lot of money. But due to the reduced refining, they gained bulk at the same strength, and that enabled them to reduce the grammage by 10%. And so they got less refining, less short fibers, more bulk, and with this the ability to reduce the grammage by 10%. And due to this, they were able really to generate 4.6 million per year of net savings, which is a huge amount of money. Because, I mean, it is net earnings and not like something which needs to be withdrawn except income taxes. Okay, last case study is testliner. Here we are the complete opposite of virgin fibers, so 100% recycled fibers. It's a modern machine, less than 10 years old, producing more than 600,000 tons per year, speed 1,300 meters, and the system charge is quite extreme. Conductivity 7 millisiemens per centimeter, and colloidal load 1,400 microequivalents per liters, and those are the headbox measurements. Zeta -8, but I think that is pretty normal for an RCF mill. They were struggling with reaching constantly the testliner 1 specification. So they were already using stronger fibers to reach it, but still they were sometimes out of spec, which means they were using more expensive fibers, but still had to sell it as testliner 2. So then they lost a bit of money. And here the dosage was higher, but that seems to be a trend. The poorer the fiber quality is, the more the strength additive needs to be dosed. We were dosing before machine chest, and they were able to dependably reach the strength specification. Even when they stopped using the more expensive fibers, the strength specification was reached. In general, we saw plus 20% burst and plus 20% SCT, and that is really a strong increase of strength. So even with the GPAM system, plus 16, plus 18% in SCT, that would be kind of normal. Okay, now I come to the second last slide. So to wrap it up, the FENNOBOND 77E is easy to use. We can support the introduction on top of what we do at the paper machine. We can do the introduction, we can support it with lab studies. Either we do it right at the customer if the customer has the sheet former, or we can do it in our application laboratory in Cologne or in Espoo, for instance, if it's in the Nordics. Yeah, equipment costs, as said, are minimal, and there's a high potential to reach significant gains in strength, which can then be converted to additional value or additional earnings for the paper mill. To summarize it in one sentence, it's an easy-to-use product, the risk is minimal, we never produced out-of-spec paper in our all trials which we ran so far, and the potential gains are huge. Okay, and now my last slide. Oh, sorry, it's still too much. Thank you very much for your attention, and I'm happy to answer your questions once we are reaching the end of the presentations. Thank you very much.
Thank you. Thank you, Christian, for your interesting presentation. Let's now go for the next one, which is from Oriol de Luis. He's a Spanish. He holds a degree in chemistry from the Autonomous University of Barcelona. Next, he joined Nubiola Pigments and became Iberia sales manager there. And since 2013, he works for MÜNZING as a sales manager, first in Iberia, next in Latin America, and lately also for the Middle East. He will talk about ready-to-use barrier coatings for paper and cardboard-based packaging for food. Please, Oriol, the floor is yours.
Thank you for the warm introduction. Bon dia. Hello, everybody. It is my pleasure to stay here today. I'm quite impressed about the quality of the presentations, but now I would like to change a little bit the focus. We have been talking a lot about pulp and paper production, and I would like to ask for your attention to discuss about the converting process in the paper manufacturing industry. We believe that this is an important topic because, as you know, there is a big pressure on plastic waste reduction worldwide, and we see the opportunity to develop some more sustainable products that can be an alternative to the plastic packaging. In that case, we assume that it is not possible to replace all the applications where plastic is present, but in some of them it is possible, offering a sustainable solution at a similar price and providing the necessary properties. So to do it, we will go through different points. First, we will talk about the company. First, the composition of the new products. Then I will introduce the two new products that I want to highlight today. We will see the testing methods and the results we got at lab scale. And finally, there will be a short summary. So let's start from the beginning. MÜNZING is a private family-owned company based in Germany. As you can see here, we have a lot of different, in the map, you see all the commercial offices we have worldwide. We are present in more than 100 countries, and we have around 660 employees worldwide. 400 are based in Germany. And it's I always like to highlight that 40% of the employees is related to R&D and applications technology. So we are very focused in customer support. In terms of numbers, our last year turnover was 271 million, and we have 6 production sites worldwide, mainly in Germany, but also in United States and in Asia, and also some technical services to offer local support to our customers. We have several divisions, including coatings, adhesives, construction, industrial fluids, lubricants, detergents, seafood. But today I want to focus in what we call process technology. Process technology covers all different applications related with fiber-based products like abrasives, paper impregnation and lamination, engineered wood, panels treatment, as well as paper. And more in detail, talking about paper, you can see that we can offer several different additives, including defoamers and deaerators, dispersant flocculants, water retention agents, as well as thickeners and rheology modifiers. This is important because we are the oldest additive supplier in Europe. We are nearly 200 years experienced company. So that means that we have a significant knowledge and we can develop really innovative solutions to the market. Also, we offer some surface modifier solutions like the Castinol for paper modification in calendar ink, the Lubaprin wax dispersion for pigment coating colors and some other applications, and the Ombresil and Bucosil range. Here we talk about barrier coatings as well as heat seal coatings. The Bucosil is the classical range, but we saw the opportunity to develop the Ombresil range more linked to the news of the current needs of the market as well as the regulations. So, when developing these novel formulations, we need to use the expertise we have to meet the requirements of the industry. Also, the products that we want to develop has to be good in barrier properties, aligned with the regulatory issues that are coming and most probably will come in the future. Another important point is this microparticle polymers. They have to be free of them, and also compliant with the plastic and plastic waste regulation, as well as biodegradable and recyclable. And finally, those products has to be available at industrial scale. So, the two products that I will introduce in the next slide has the following common properties. They are ready to use water-based products with self-film forming properties, good barrier properties, and based on natural raw materials. When we talk about good barrier properties, we talk about water repellent effect, good water resistance in terms of COP test, as well as grease resistance. They are suitable for monolayer coatings or even for top coatings, not for primers. As you can imagine, these are hydrophobic products, so it's not possible to recoat them, usually with water-based materials. They are based on renewable organic content, minimum content of 90%, according to the ASTM D6866 carbon-14 method. Really biodegradable, and has to be or must be applicable by the most standard systems in the industry, as well as compliant with several food contact regulations. The two products that I want to introduce today is the Ombresil 3320 and the Ombresil EXP B50/8. The first product, Ombresil 3320, is free of microplastics according to the EU 2023/2055. It's good for oil and grease resistance as well as water vapor barrier. 40% solid content and activation temperature around 90 degrees. The second product is the XB50/8. It's also good for oil and grease with higher improved flexibility. The solid content is slightly lower, 33%, and the similar activation temperature around 90. In the testing part, we have also included a reference product, which is a ready-to-use water-based film forming dispersion, but in that case is based on fossil-based binder raw materials. This product provides high oil and grease resistance, very good water resistance, as well as water vapor barrier. So let's go to the testing part. To do the testing, we select two different base papers in cooperation with SAPI. The first is the MLCAR 15. It's an uncoated paper, calendared with a specified COP60 value of 27 grams per square meter and a grammage of 67. And the second paper is the Silco White BS, which is both sides pre-coated with a synthetic polymer binder, calendared and compressed glassine paper, specifying COP60 value of 17 grams per square meter, and the grammage is 62. The materials at lab scale has been applied by spiral route. The coating wedge is 6 grams square meter dry, and it was dry and activated by applying hot air blower at 130 degrees during 60 seconds. And we saw that this method is more realistic rather than putting the samples in the oven. That's why we used to do it in the lab in that way. Finally, the panels were conditioned during 24 hours at ambient humidity and temperature. So the first results we saw here is the moisture-vapor transition rate. As you can see, we test in two different conditions. On the left side is the standard conditions, on the right the tropical. It is clear that the uncoated, the non-pre-coated paper has higher absorption than the Silco White BS. And you can also see there is a significant improvement by adding the 6 grams per square meter of the XP B50/8. That can be enough for some applications, but maybe not for all of them. That's why we also test the reference, and you can see here a big improvement, which is also expected with the fossil-based material. But the Ombrasil 3320 is not far away. If you see at the MLCAR values, we are talking about 6 in terms of difference, and in the Silco, the difference is also not so high. It's only 11 grams per square meter a day, so it's good result. It is even more surprising when we jump to the tropical conditions, because you can see here the absorption of both papers is much higher. In both cases, we exceed 1,000 grams per square meter a day. With the Ombrasil XP 50/8, we reduce it significantly, especially with the pre-coated material, and the reference give us some good values, really nice values, 150 and 140. But it is even more surprisingly that the Ombrasil 3320 reduce by 1/3, more or less, the values that we got with the fossil-based material, which is really impressive, I will say. Just to clarify, we expose the coated side through the atmosphere toward the test climate, because that way we control better the absorption of humidity on the paper. Second test was the oil and grease resistance. In that case, we didn't take the kit test option, because we know that the industry is moving forward to this method because it's not really realistic, and we decided to do the palm kernel oil test. This is based on the DIN 5316. This is a very common oil in all the kitchens, probably not in Portugal or in Spain, but in other countries. So we applied this in these small 5 windows you can see in the image. The excess of the material was removed, and then this paper sheet was pressed within 2 plastic sheets and put it in a climate chamber. After that, we analyze the penetration, the leakage on the control paper. This method gives us 5 different categories exposure. The climate change, the climate conditions are always the same, 20 degrees and 50% relative humidity, but we can play around with the pressure and the contact time. In that case, we focus on the category 3, which is 2 kilos and 1 hour contact time to make this comparison test between all the samples. So, on the left side, you see the reference, fossil-based material, looking perfect with the Silco White, with the pre-coated, with just some small dots in the MLCAR. But when you compare with the Ombrasil, you see that these small dots completely disappear in MLCAR and looks perfect in both. So, great result also in terms of oil and grease resistance. That's not exactly the same when using the B50/8. In the Silco White, the results are still very nice. But on the non-pre-coated material, you can see that there has been some penetration, there's plenty of dots. So at some point, it is not powerful enough for some applications. Another important thing when testing this material is the blocking. You know that sometimes during the rewinding process, especially when applying these materials, it's very typical to get some stickiness, some blocking. So that's why we do this test. We exposure the panels 24 hours at 50 degrees with 50% relative humidity and a loaded weight of 10 kgs. And as you can see here, the material based on fossil binder got some damaged surface. It's a score 3 on this rating, whereas the uncoated and the 2 new products were rating 1. So there was no addition at all, so no blocking problems, which is also very interesting results. Finally, talking about gluability, we know that these water-based materials provide some repellent effect. So it is possible always to use hot melts for gluability purposes. But in that case, we got in contact with Jowat adhesives to also check the suitability of water-based dispersion glues. In that case, the material selected was the Jowat 732.20, which is standard dispersion for folding box board. And we test in two different conditions. First is no plasma pre-treated, and the second is with plasma pre-treatment. You know that this plasma at some point can improve the adhesion, so we want also to compare the results at this respect. The sample with the ML card paper coated with the ombre seal and no plasma treatment result in excellent bonding, 100% fiber tier at -10 degrees, and very good high bonding at both 5 degrees and room temperature. When jumping to the pre-treatment with plasma substrate, we saw same result at -20, perfect bonding, also at 5 degrees, perfect bonding, and high bonding just with partial fiber tear and adhesive failure at room temperature, which is quite good result as well. For your information, the pressing time was 3 seconds with a steel roll. So, summary. As a conclusion, we can say that we have developed some cell film forming materials ready to use barrier coatings made with renewable raw materials and also biodegradable that can be used as a single or top coating. The processability on different industrial application systems has been proved. We have several examples in different systems. Some of them, like cordon coatings, will be tested soon, and but we are quite optimistic. Also, the result will be positive. It is possible to adjust the material for rheological purposes. When the material is too thick, it can be adjusted with water, always controlling that it is stirred properly before using. Those products cannot prove repulpability on its own because it also depends on the complete system. But regarding some projects we did with some customers, we prove that all of them are, so it's also good news. Also, it has been proved that the barrier performance depends on the substrate as expected. These coatings will be scaled soon. In fact, the 3220 is already available. It's a standard material. We develop few batches in production, and with the V15/8, we expect to have it soon because it's still on aging tests. And finally, the machine at industrial scale also proves very good processability and excellent results. We do some trials in Comexi. Maybe some of you know this company. It's based in Girona. They are quite strong in printing solutions, and we do some trials with some customers showing very nice results, as I said, in terms of processability and barrier properties. Disclaimer, we talk about the EXP. X means experimental. So just for you to know, it's just let's say, common information. That means that it is experimental. So we develop these products in cooperation with customers. We are quite strong in tailor-made materials. Because of that, the production process, raw materials, and specifications can change when we move from experimental to standard material. And also, the manufacturing of these experimental products frequently takes longer because we are using new technologies, new materials that usually are not so much available. And last but not least, just also some contacts for you. In Portugal, we work together with our partner, Biermann. Ines is the responsible for the paper industry. Ines and Luis are today with us. Thank you for coming. Also, we have a new acquisition in the company. Fabio, welcome on board. He is new in the company, but he will provide us a great support because he is a very experienced guy in the paper industry. I'm based in Barcelona, and as I said, our headquarters are based in Germany. So we all will be happy to discuss future projects and ideas with you. Thank you very much for your attention.
Thank you, Oriol. Thank you for your presentation. Let's now move for the last presentation of this paper session, which deals with the use of non-wood fibers for tissue papers. The speaker is Ronalds Gonzalez, Associate Professor at North Carolina State University, specializing in conversion and process economics with a focus on the pulp and paper and the hygiene tissue industries. He's a consultant and aims to advance sustainable practices in fiber-based consumer goods. Has been a regular lecturer at BOCU, also at Aalto University, and here in Portugal at Universidade da Beira Interior. Please, Ronald, the floor is yours. Let's try to finish by 12 since another session begins next.
Sure. I always speak fast, and this time will be faster. So let's see how that works. Hey, good morning, everyone. So each of the topics have been different, and this also will be. And this is about alternative fibers and sustainable fibers with a focus on hygiene tissue paper. So the very first question is, why alternative fibers? And I'm going to give you some data on this. The very first thing is because of the digitalization. We have seen how we have been losing production capacity for printing and writing paper, right? It's very straightforward. This graph shows that in the US and Canada alone, in the last 20 years, we have lost 20 million tons capacity. Our prediction is that we're going to lose other 45 to 50% in the next coming years. Now, some people will say, hey, you are overreacting to this. This is a real number. Well, in 2023 alone, we lost about 20% capacity for this. So this is going to get worse. Now, why is this important? Well, when we look into some of the market, let's say specifically in the US, we use about 28% about the ink pulp. In the Mexican market, about 65% of the raw material used is recycled fibers that are used for hygiene tissue paper production. And in Colombia, it's about 75%. I'm going to give you some additional information on this. Delivered SOP, sorted office paper, recycled paper, in Medellin, Colombia, has been for about $400 to $480 a ton with a 61% yield. Now we're talking that it's almost $750 per ton on average. That's even more expensive than buying BEK from Brazil. But of course you say, okay, yeah, can they use BEK? Well, they remember that they have different grades in tissue paper, low, economy, premium, and ultra, right? Just to give you another sense of information about how this has been changing, 10 years ago, that bale 1 ton of SOP was about $150 per ton delivered, and the yield was about 71%. So this is going to get worse. Now, let's see what happens with virgin fibers. We have seen and we have heard and we have witnessed the increase for hardwood, BEK, for tissue making. But that is not the same for long fiber NBSK. What we see is that there will not be increase in production. Some of the remaining capacity have been bought by Asian firms in order to secure supply for their operations in Asia. Then it is not difficult to expect that prices are going to go up. So with that all, I think that we have layered the floor to say that there are some opportunities to look for some fibers that we can use in the hygiene tissue operation. And I'm going to give you a sense of some opportunities that we have been working on. So this graph shows you a couple of things, and of course there is a lot of data. And the intention of this is that you can come later and ask me about, okay, what do you want to say with this? In this graph, we have different combinations at the bottom of raw materials, traditional, conventional fibers. And as we move to the right, then we have alternative feedstock. When we say alternative feedstock, what we mean is bamboo, grasses like miscanthus, switchgrass, wheat straw, and other agricultural residues. 2 lines, you can see the tensile strength in blue and the softness in green. So every time one of the bar touches or surpass the blue line, then has met the tensile strength. And then when the line touches or surpass the green line, then it has met the minimum softness. Of course, we know that tissue paper is a multi-attribute product, but we are trying to make the story very, very quickly on this. And with this, what we want to show you is that we have found so many opportunities, so many feedstock combinations that actually can pass the test of what we're looking for. But it's not only about the properties, but also additional opportunities. And this is a concept that we have been working at NC State University, and I'm going to show you this with a picture. When we begin doing some blending, when we use, let's say, wheat straw, this is a typical web of tissue paper. It contains, in this case, 85% eucalyptus short fiber and 15% long fiber NBSK. We have not added any wheat straw, any material, right? When we add wheat straw at a given amount, we have seen that some of the properties improved. But now, instead of saying that it's 30 GSM, it's 27 GSM. So this means that the possibilities of using this alternative feedstock, but also reduce the amount of fiber that you're using in this. It has been very interesting as well that when we began our journey, we were looking into these alternative fibers. Again, switchgrass, miscanthus, and they are short fibers. Our first rationale was what? It should complement or replace eucalyptus short fiber. And that actually was not the case then. We realized that actually it was the case for long fiber that needs to be complement or replaced. Well, this is no lab scale. We are seeing the presence of these products on the shelf in different markets. This is Zigua, SET, and they use wheat straw produced in their Mannheim pulp mill in Germany. This one is Black Satino on your left. It's from the company Webpa, and uses miscanthus grown in the Netherlands. Now we have to talk about the challenges, because of course we talk about the opportunities, so what are the challenges? When we talk about agricultural biomass, agricultural residues, or planted crops, one of the very first things that it comes to our mind is that there is a low yield on an acre basis compared to eucalyptus plantations and other forestry systems, right? So that means that eventually you will have a longer, higher radius of supply compared to a traditional forest production system. The other part relates to bulky biomass. They are very, very bulky, and that translates into what? High transportation cost. Then, because a combination of this, it has come to, let's say, to determine that very likely this operation will be less than 200,000, less than 250,000 tons in order to have afford those biomass delivered to the mill in a competitive price. Because this limitation in terms of scale of the supply, then we also see that the situation about a chemical recovery is no longer possible, and this is strictly because of economics, but also then the opportunity to reuse some of the spent or chemical liquors that can be used as a byproduct in the process, and also for, let's say, as a fertilizer amendment, a soil amendment. Another problem relates to the fines. Yes, alternative feedstock, switchgrass miscanthus has a lot of fines. And can this be a problem? Yes. Actually, there was an investment in the state of Washington, Columbia Pulp Mill, and the major failure for that mill, 140,000 tons a year that was planned, it was built. And one of the major failures was that the people behind the investment, they didn't realize the effect of fines, and yes, fines can be a big problem. But since then, a lot of technology has been developed and knowledge in terms of how you can improve or reduce the effect of fines in a system. Like this is, for instance, a mechanical process, APMP, then how it can be treated at the beginning, the proper handling of the material, washing, and then maybe some purge after the refining to decrease the amount of fines. The other part that we want to talk is that the fact that a fiber is alternative, it doesn't mean that it is more sustainable. And we have to be very careful with that. We published a paper a couple of weeks ago where we showcase that if we made tissue paper from bamboo, actually there is no environmental footprint savings in terms of carbon footprint. When we compare bamboo versus eucalyptus, actually we see that eucalyptus produced in Brazil actually comes ahead. Now, this is nothing wrong related with bamboo. It's just the fact that how it is processed and produced in China and because of the reliance in coal. Now, if this bamboo would be to be produced in US or in Brazil, then the story would be different. Then there is another paper that we're going to publish, and this compare the carbon footprint of, let's say, wheat straw pulp on your right versus sourcing wood fiber from a primary forest in Boreal Canada. And what is a primary forest? Well, primary forest means a forest that has never been harvested before, has never been touched, and then that first process in the conversion from primary forest to working forest will release a lot of carbon footprint. So I think with that, I want to move on to present ourselves in terms of what we do. We are SAFI, and it's the Sustainable and Alternative Fibers Initiative. Our goal is very simple, is to develop knowledge that can be used by our partners. And that knowledge can be related to the carbon footprint and also sustainability attributes, but also all the technical aspects. We have been receiving support from different organizations, including Rockefeller Foundation, Climate Breakthrough, and Canopy. And we have most of the big brands that are supporting our work. The way that we work is that we go across the whole value chain. And that means feedstock and supply chain, like the map. We understand where the feedstock is, what is the cost of growing the biomass, transporting, harvesting, all of that. Characterization of the feedstock before we send it to the reactor for pulping, the conversion or pulping, fiber and product performance to understand how that fiber compares to the benchmark or how can complement different products. Techno-economic analysis, because then we have to put some constraint in terms of cost, cash cost and capital investment, life cycle analysis, and of course, consumer perception. We produce a booklet every year that we share with our members, where we showcase the different samples, properties. I mean, we do all this in our labs so they can see the different properties for tissue paper, for packaging, even for man-made cellulosic fiber from alternative feedstock. As we said, that we work into solving real-life problems. This is one case. For instance, as we know that there is an issue related with recycled fibers, as we mentioned before. Okay, what happens if we can use some of these brown boxes from Amazon, OCC, and then to use that in hygiene tissue paper? Of course, one of the biggest challenge relates to the bleaching for that, and of course other property, and we are tracking on this, and actually that's possible. I showed you a picture a couple of slides ago of a product called Mashed, and it's from the company WEPA, where they are already using OCC in their operations. And so with that, thank you so much for your time. I think I delivered on time, just maybe have 1 minute left for you, so we can use that, right? I will be very happy to answer some questions later on, or just to exchange a business card. Thank you so much.
Thank you, Ronalds. Well, I don't know what Gabriel thinks, because he's the chair of next session. Do we have time for 1 or 2 questions, or should we start your session? Okay, so we have time for 1 or 2 small questions, please. Feel free. Otherwise, okay, there.
Thank you all speakers. I have one question for Oriol, if possible. I understood that your coatings have a slight difference in performance when applied to the different substrates. And I wonder if you can elaborate a little bit on what was causing that regarding the surface properties of the substrate, either the roughness or the chemistry behind that. Okay, thank you.
Thank you. Yeah, it's working? Thank you for the question. Yeah, that's a really important topic. I will say when you try to develop this kind of barrier coatings, the first thing that you need to analyze is the quality of the base paper. Of the base paper. How do you do it? You need to check several properties. Usually we usually focus on the COP60, but this is not only the key property to get a good barrier effect. Of course, you have to have a look on this, but it's also very important you try to get a very smooth surface. And that's why you can see the significant difference with the pre-coated and not pre-coated. Because if you have a really rough surface, what you will achieve is you will not completely close the surface. This is why I mentioned this is a film forming product, but at the end it's a film forming if you have a very smooth surface. So I will say the two parameters is first the absorption, because if you absorb the material, these are surface additives, so you wouldn't get any barrier effect. This is the first thing. And the second is try to get as much smooth paper as possible. Combining these two properties, I think it's the key of the success with the barrier coatings.
Any other question from the audience? Well, if not, maybe we should go to the next session. Join me in a last applause to these three very interesting presentations.